Okay, so this is the final explore in our first lesson. It's going to be really pretty short. We've talked a lot about this before, so it's going to be a short lesson talking about the star life cycle and talking about the heavy element formation. You should find a lot of this to kind of be review from our previous lessons. And then you'll have, again, the short homework component to work through and turn in. After this, you'll do the lesson self-check, and that will hopefully show you kind of what you've learned and what you know. And again, if something isn't making sense, just let me know. All right. So as we're looking at this lesson, we're talking about the cycle of stars again and focusing on the fusion of stars and how that is going to create the different elements. This is the image from your book. The thing to keep in mind with the star formation is the amount of dust and gas that starts just the mass for the star is really going to determine the type of star and the pathway that it's going to produce. So you can have anywhere from the blue supergiants, right, all the way down to our sun-like star, and then down to like the dwarf stars. So we'll talk about kind of the differences seen in those. You've seen this image before. We have this nebula that is going to produce different various sizes of stars, and then that production will go through it. One thing that we haven't talked a lot about is the core of the red giants. So we've talked about hydrogen fusion and the helium that exists in a star and how different elements can be produced from different fusion reactions. If we have a red giant, we actually are going to have different cores for those fusions. So a massive star is going to have an iron and a nickel core, and then from silicon to carbon to helium, and at the end you're going to have nitrogen, helium, and hydrogen. And so you have all of these larger elements that are being produced, and then in the smaller stars, you're just going to have hydrogen and helium within them. And so once you have those kind of baseline elements produced, if this star goes into a supernova and explodes, that excessive force is going to form the higher elements of that we know exist in our solar system. So this is a different flavor on your periodic table where you can see where these different elements come from. We can see from the Big Bang, we get our kind of building blocks of hydrogen and helium. And then massive stars or merging stars or low mass stars are going to produce the different elements that we see within the universe. So this is just, again, another way to kind of think about this, where it's all these fusion reactions. And the reason that these larger elements are more rare is because they're only produced in that supernova state when a star dies. If you'd like to, you've seen part of this before, but again, I'm going to put it in here. The Professor Dave video that walks through the life cycle of a star is really good and goes more in depth than our book in terms of what this process looks like. But as long as you're understanding kind of this component where we have the different layers based on pressure, temperature, and the forces acting on them, and then that supernova event that is going to produce these larger elements. All right, so we'll look at the homework in a minute, and then you guys can, again, think about how you're going to wrap up this part and take that lesson self-check.